Hey everybody, this is Alex Merced from alexmercedcoder.com with another video on the OCAML programming language. Again, this is a video to be a more sort of friendly introduction into OCAML, just because I don't find a lot of accessible explanations of this language out there. A lot of it's either whoever is presenting it isn't the most charismatic person out there, or they're using a lot of verbose language because it's really kind of geared towards more advanced programmers. But I would like to make OCaml something accessible to everyone. And if you hear my bird, that's my cocktail Wally there in the background, always having to heckle me while I talk about code. But let's create a new project. So again, if you haven't already, you can go to OCaml's website, install OCaml, which would mean you would need to have Dune installed. Dune is the build tool. Okay, so Dune version. Then you also want OPAM installed, which is the package manager. There's also SE. SE is more if you're using Reason. And again, Reason is sort of a dialect of OCaml that's built to be sort of like JavaScript-y. And I will come back to Reason at a later point. And Rescript and whatnot. Right now, I just really want to kind of focus on just OCaml as a standalone language, not necessarily in web development, just programming in OCaml. So what I'm going to do is I'm going to create a new folder, and we're just going to call this my teaching folder because I'm going to be doing all these videos in this particular file. And I'll open up the terminal in that folder, and I'm going to just use Dune init. I want to do an executable. And we're going to call it teaching. And that'll create it in that folder. So now see, ta-da, all the files. Okay, this Dune file, this is kind of like your package.json. Basically has metadata. This is just where all your build stuff going on. You really don't have to touch that. And here's your file. Cool. Okay. So what I want to focus on this video, I'm going to more slowly kind of go over some of the basic syntax. But bottom line is this. The way OCaml works, and the way sort of the ML language of families works, is everything's an expression. And this is the same thing in JavaScript. You have a sequence of expressions, but every expression is being bound, and you're binding that expression with the word let. So let is not necessarily assigning a variable like it's in JavaScript. What you're doing is you're saying, here's possibly, if I'm just going to do a thing, I'll just do that. Okay, and then I put my expression afterwards. But if I want to bind the result of an expression to a name, then I can just say let my number equal 5 plus 5. Or I could just sit there and say something like 5 plus 5 plus 5, which would be, we'll say plus times 5. Because order operations is what occur first. Because technically, if it was 5, if I didn't use the parentheses, it would be 5 times 5, which is 25, times 5, which is 125. But in this case, it's 5 plus 5, which is 10, times 5, which is 150. Okay? So what this does, it takes the value of this expression and assigns it to this namespace. Okay, and it's not just expressions, I could also assign all sorts of different stuff to it. But basically, whatever's after the equal sign is going to, this is going to equal that. Okay, then you're going to use 2 semicolons to say, okay, this is the end of this sort of line. So then on the next line, I don't want to save the value, so I just want to do a thing. So I'm going to put the parentheses to just say, hey, I'm doing the thing. Okay, and what I'm going to do is I'm going to use this print endline function. Okay, print endline, which just prints a thing. And now my number is technically of type. It's going to be an integer, because see, 5, these are numbers, these are integers. Print endline needs to print a string. So I need to take that integer and turn it to a string. And I can do that by doing string of int. So if it was a boolean and I want to turn it to a string, it would be string of bool, float into a string, float of string, etc. So I do that and pass my number into that function. Okay, and generally, like any programming language, best way to think about it is goes to the innermost parentheses and work your way out. So this function runs first. So first my number happens. My number is going to be 150. let me see here. 5 plus 5 is 50 times 5. No, 5. That's going to be 250. Okay. So you'll have 250 here. That 250 gets turned into a string, and then it gets printed. And then I need 2 semicolons. So let me print this out. So I'm going to run the build command. Dune build. That's going to build the thing. Okay, so now technically there's more stuff going on here with the resulting code. And I can easily run it by just doing dune exec, meaning I'm executing. And then you're going to type in the name of the file, which is teaching.exe. Even though there is no exe file because I'm on Linux, it still kind of requires this in this particular context. Okay, oh, that's right, I always make this mistake. You probably saw me do the same mistake in the previous video. You have to put the dot slash in front of it. Okay. And there you go. See, I get 50. Let me think about it. Oh, no. 10 times 5, which is 50. Okay, you can tell it's a Monday morning on a holiday. Cool. So that's the basic sort of like syntax. So it's not too bad. It's not too far from what you may used to be used to with other programming languages. Okay, I'm just basically saying command. Now, a couple things to keep in mind. Now that my number has a value, that value will never change. Okay, ML is a functional programming language, which means variables are immutable. Now, there are some things around, like ways you can kind of work around that, but the general idea is that basically functions should always be sort of returning a new value. Then you're going to use that new value. So essentially, what you're doing is you're not necessarily updating or changing values of variables. You're taking variables and then replacing what they're holding with the new value. So it's more about replacing. And if you ever use like React, this is very much part of how React is designed in JavaScript. So if you ever like the idea of state, you're never really updating the state, you're replacing the state in JavaScript. So if you can understand that, then this is going to be not too much of a leap. And actually, Facebook was very involved with the creation of Reason, and Reason is the dialect of OCAML, this language, created and actually is used at Facebook quite heavily. So you have a lot of functional programmers. I think, like, basically I was doing some research, and I think what happened is that, like, OCaml, the language is kind of big particularly in France, and then Facebook hired a bunch of like French developers, and that led to sort of the influence of OCaml and functional programming, and React and all these kind of things. So just a little lineage there. Okay. So next thing to learn is that we can also create functions. So if you're familiar with other programming languages, you can create like things you can reuse again to do certain like commands. So in this case, like print nline is a function, and I can use that over and over again. String of int is a function, and I can use that over and over again. And I can pass it information inside these parentheses for that function to do things for me. But I can create my own custom functions. So let's try that out. So let's call this print num. Okay, print num. And it's going to take one argument that we're going to call num. Okay, and that's basically the syntax. So basically we put the name of the function and then the arguments of the function afterwards. And you can actually put types here too. So like ML is a type language. So if I remember right, I think it would be like int num, kind of like that. I might have it backwards. Let's try it this way. Yep, seems to like that way better. Yay for IDE linting. Okay, so basically it takes one argument. That's going to be called num. It's an integer. Okay, and basically what it does is going to take whatever num is, print nline. Okay, and then it's going to take that, basically the thing we just did a second ago, string of int, and then take num and print it. And then that's what this is going to do. And why doesn't it like that? This expression has a type unit, but an expression was expected of type int. Oh, that's... oh, it wants me to return an integer. I think I want to do something like unit. Does that work? something like that. Okay, so what I can do there. See, basically what happens again, functional programming languages always want you to return a value. So in this case, they kind of want me to return a value of some sort. So maybe if I do this, just in 5. Yep, that doesn't quite fix it yet. Expect of type int. Expression as a type unit. Okay, I guess I'm going to have to Google how to type the function, or I can just make a simpler function. That would also be a possibility. Okay, so I'd have to type this function as a unit. Unit is basically the equivalent of void. Now, void in other languages is generally used to mean like a function that returns nothing. In here, you would say it's of type unit, and unit means it returns nothing. But, well, I remember the type parameters. I'm forgetting at the moment how to type the function itself. So in that case, what I'm going to do is just make a simpler function. So we're just going to say we're going to take num plus num. So this is just going to be a normal run-of-the-mill double function. Double the num. Okay, there's our function. So now I can do this. I can be like let, and then again I'm going to go print end line, and again I got to convert the string into an int, or the int to a string, and we're going to double the num, and we're going to double the num of 5. And we'll try this a few times. That's to show that the function is reusable. Okay, cool. So now we build, Dune build. Then I'm going to run the file Dune exec dot slash teaching dot exe. And there you go. See, this is like double 5, double 12, double 14. So I can create this function. I created this function double the num that is that I can use over and over again. So that's the beauty of functions. That's how you would declare functions. There's actually a couple different ways of declaring a function in OCAML. I'm just going to use this one. It's the most succinct one, and I generally like succinct. So you can read the documentation if you want to see the other ways. Okay, one more thing. Let's talk about records. So you might be familiar with like key value pairs. Okay, whether they are like a dictionary inside Python or an object in JavaScript, or a struct in languages like C, Go, etc. So you have something like that here. It's called a record. Okay, and if you want to declare a record, it would work like this. So actually, let me just delete all this. Boop. Okay, we're creating a new type, and we'll say the type is called person. Type person equals, and we'll say it has a property called name, which is a string. Now here's where it gets a little weird, because if you use JavaScript or many other programming languages, you would naturally think the next thing I'm going to type is a comma. And no, it's going to be a semicolon. Okay, name string, and what isn't it not like about that? Oh, well, we'll finish that. Type person, and then we're going to say age int. Okay, did I forget something? Let me check. Do type person. Yeah, that's basically what I did. Type person string age. Yeah, that's what I did. So I think it just doesn't like that I did this in uppercase. Yep. Okay. I don't need the second semicolon, so we'll just send that here. And now I can actually declare variables of that type. And oh, I need 2 semicolons because this is OCAML. I know that's how OCAML works. So we can say let Alex, that's my new variable, equal. Let Alex equal. And then we just say name. And then again, you'd think I would put name colon the value, but nope, it's going to be name equals Alex Merced and then semicolon. age equals 35. Okay. And now I can actually use the properties. I can actually go use this object. So I can be like, let first, we'll print the name. So let print nline. And now the name is already a string, so I can just pass a string. So I'll just say alex.name. That's simple enough. And then make sure I end all these expressions. Okay. And then say let, now the age is an integer, so I gotta typecast it. So print nline string of int to turn this int into a string. What am I turning into a string? I'm turning alex.age into a string. So alex.age gets turned into a string. That's 35. That's a string. Then that string gets passed into nline. Okay, so there's our program. Now let's build it. Doon build. And then doon exec. Teaching. Oh, nope. /teaching exe. And there it goes. It works. Okay, and then I could go from there. So that's, again, our initial start. So that kind of goes over what I did in the first video, but just a little bit slower, with a little bit more explanation. And also we learned about records and how to kind of define these like key value pairs and the syntax for that. So that way you can define your own types of clusters of information. Okay? Because you might want to have, like, again, in this case, a person, and you want to basically say, hey, I want to create a variable for Alex, I want to create a variable for Bob. So by defining all the properties of a person, I can then do that. There actually is also classes. So you can create classes as well and instantiate classes. That's why I think that's what the O in OCAML is for, like object-oriented ML. But yeah, so there we go. I'm going to leave it at that for this video, but I'll see you guys in the next video. We'll keep just kind of incrementally learning OCaml. I think it's kind of a neat language. What I like is this, like, sort of like thinking in this way, just thinking, instead of thinking of assigning a value to a variable, thinking of assigning an expression to a variable, like this sort of like the let binding way of OCaml doing things, I think is an interesting way to think about it, especially if you've been used to like Python, JavaScript, Ruby, just like a lot of the more sort of traditional languages where the way you think about it is a little bit different. And it's useful because actually I do find myself sometimes, even if I don't spend a lot of time doing OCaml code, learning some of the ways you do things in OCaml have affected the way I code in other languages, because it's helped me to sort of think about what my code's doing in different ways. So I do think it's kind of a worthwhile endeavor. So you guys have a great day and enjoy. My name is Alex Merced from alexmercedcoder.com. Go join the Slack and Discord community over there at devnursery.com, and I'll see you guys later.